All right, hello and welcome to a new week. We have loops on the agenda for the day. So, let us talk about those. A loop is just a piece of code that can come back to itself. It's wonderful. All right, so let's do it. Let's get right on into loops. Maybe I should motivate them for you a little bit just before we get started. So, remember that example that I gave of the guess the number game where I copied and pasted a ton of stuff just because I didn't know how many times the user was going to want to type numbers or keep messing up. That was the only thing I could do to solve that problem right now. Okay? And that's not good enough. Silly notification. That's not good enough. We would like to be able to repeat that code as much as we want, right? We would like to make a program that can revisit and rerun its code until we ask it to stop, okay? That is what we want. Because our programs, they don't have this picture in them yet. There's no way to come back at previous code. The only thing that our programs can currently do are straight line stuff. And then we also learned how to branch, right? We can go off this way, do some stuff over here, do some stuff over here, alternatively. And then we can come back and do some more straight line code, okay? But the one thing that's missing is, like, the holy grail would be we want to branch and come back and also go back to the start and repeat, okay? That arrow that goes back up, that's a loop, okay? We like to add those things called loops to our programs that let us revisit our code. So let me show you how to do it. There are a couple types of loops in C++. The simplest one is called a while loop. Okay, it looks very similar to an if statement. You just have while instead of if. Okay, so here's what happens in a while loop. You can have just normal code up here, whatever you need, and then it plops you into a while loop when you write one. Okay, so when you say while, just like for if, you put in parentheses a Boolean expression, something that could be true or false, and then, as long as this expression is true, the body gets repeated. Okay, that's a while loop. So it's like, while this is true, continue doing the body. Okay, continue repeating the body, and then checking to see if the expression is still true. Okay, so it's always do the body once if it's true, go back, test again. Hey, is it still true? Okay, I'll do the body some more. Test one more time. Okay, yeah, it's still true. I'll do the body. Oh, now it's false, because something in the body changed that Boolean expression's value, and now I can do the rest of the code. Okay? That is how a while loop works. So this body is always going to get repeated while the expression is true. The expression evaluates to true. Okay? So let me give you the simplest possible program. Let's print first. Let's just do printing. Let's print the numbers from 1 to 10. Okay? Let's do that. Let's see. Yeah. First print, and then I'll do summing the numbers from 1 to 10 after that. Okay? Print 1 to 10. That's CPP. So here's how you do it. What we need is a special counter variable, usually called I. Okay, I stands for iteration, because loops iterate, we say. So I'm going to start I at 1, and then, as long as while I is less than or equal to 10, because I want it to range between those values, between 1 and 10, I would like to output the current value of I, whatever it was. Starts at 1, right? So output my 1. And then, so that I'm ready to do the next thing, the next number I want to print using I is 2, so I better increment I plus. Okay, so now I is 2, and then a while loop will go back, check this condition. Oh yeah, 2 is still less than 10, so I'll print the 2. Make it 3. 3 is still less than 10, I'll print the 3. Make it 4, etc. until it's finished. So that's print 1 to 10. And then I'll do, let me make this a little bit bigger, sorry. There, and it printed from 1 to 10, yay, look at it go. So that's how it worked, And let's talk about that in a bit more detail. So, diagram of how the code works. Let me show you. So here's my code, and here's what's happening. Because we want to print, right, from 1 to 10. We want to end up printing 1 to 10. How does this actually do that? So I start my I variable at 1. Okay, that's what it begins its life with. And then the while loop is always going to do, check the condition, do the body if it's true. Repeatedly do that until it's false. Only then do we stop doing the loop. Okay? So I starts out as 1. 1 is in fact less than or equal to 10. And so we're going to print our 1. Okay? That's what's going to happen. We're going to print our 1, and then we're going to increment I. Make it 2. And then we're going to go back to check the condition. Hey, is 2 still less than or equal to 10? Yes. Yes, it is. So we're going to execute the body again, which involves printing our I, incrementing our I. 3. Same for 3. 3 is less than or equal to 10. Print it, increment it, make it 4. And then eventually, it'll get all the way down to 9, right? So we print our 9, increment it to 10. 10 is still less than or equal to 10, so we're going to continue the body one last time. Print the 10, make I 11, woohoo, and then this now is false. 11 is not less than or equal to 10, so we're done, and we get back down to here, we're done with the while loop. Okay? So I is in fact 11 right now, if we were to print it out. See that? That's interesting. But that is, that's how that's working. So that's just printing the numbers from 1 to 10. If I would like to sum the numbers from 1 to 10, what I can do is essentially something very similar to this, where instead of printing, I'm just adding into like a sum variable. So maybe instead of I, I'll start my j at 1, and then I'm just going to repeatedly put it into a variable. Set sum to be whatever it was plus j. So make it 1. And then I'll increment j to 2, because I want to add all the numbers between 1 to 10 into the sum variable. Okay? And so now sum will be 3, because it was 1 plus the 2. Now make j 3. Whee. And so I'll add the 3. Now sum is 6. And I'll keep doing that as long as this j is between 1 and 10. So add the 4 into sum. Now make it 10. Dot, dot, dot. All the way to 9, which I think is going to end up being 45 eventually. And then the last time we add the 10, it'll make the sum 55, because that's the sum of all the numbers from 1 to 10. And then we won't add anymore when j becomes 11, and we increment it one last time. Okay, so this idea, let me code that up, and it should make some more sense. Sum 1 to 10.cpp. So I'm going to take this code, do almost the same thing. I'm going to instead have a sum variable, start the sum at 0, and instead of this, I'm just going to add sum equals sum plus I. Add I into sum. I guess in my example I was using j instead of I, so let's take care of that. Yay. So now, j is 11 by the time this is done, and sum is the correct sum of all the numbers between 1 and 10. Boop. Yay. It's 11 and 55. I don't add the 11, right? Because once I make j 11, we're not continuing the body and we're not adding into sum anymore. But I hope you can see why it's summing all the numbers between 1 and 10. We start our sum variable at 0, and we repeatedly add j. Sorry, I forgot the comments. We repeatedly add j into the sum variable. And so j is going to have a chance being all the numbers between 1 and 10, right? Because we're incrementing it. And it's going to get added each time into the sum variable. Once it's done, we've added every of those 10 numbers. All right. Hope that makes sense. And so it's following along this process. That's how you sum the numbers from 1 to 10, as well as print them. Okay? So I hope that makes sense. And what I'd like you to try now is change the following code, this code right here. This one is essentially what I just wrote, right? Printing from 1, yeah, this one's printing from 1 to 10, it looks like. Perfect. Take that code and change it so that it prints from 10 to 0 by 2s. See if you can figure out what to change. All right, what are your ideas? So the very first number that's going to be printed is the initial value, right, of I. So if I want to print 10 first, I better start out as 10, right? So that needs to change. I need to change the starting value to 10. That should fix it. And then I want to print my number, and the next time I come around to the while loop, I want it to be 2 less, right? I want it to go from 10 to 8, so this has to change, right? This has to change from I++ to something like I equals whatever it was minus 2. Yeah, I'm going to decrement I now by 2. And then also, this condition needs to change as well, right? Because if I start at 10 and go downwards, yeah, I is always going to be less than or equal to 10. And it'll just print until the end of time. We want it to eventually stop once it gets to 0, right? And so we need to change this to something else. Something like while I is greater than or equal to 0. Okay, that'll fix it. So let me show you this code and why it works, and that should be that. Whee. Print 10 to 0.cpp by 2's. So taking our starting code, I want to start I not at 1 but at 10. I want I to go until, because it's decreasing, right? I want I to go as long as it's greater than or equal to 0. And then every time I print a number, I want to decrease I by 2, because I want to count downwards by 2. Oops. Whee! And so here's how it's doing. 10, 8, 6, 4, 2, 0. And so it stops once I hit 0. That's the last time this is true. Okay? So think about why it couldn't be the original condition, and we'll talk about infinite loops later. All right. So that's that. I would just like to take a moment to just take a step back and celebrate something with you actually right now, because this is a huge moment. Right now is a huge moment for you, because I'm sure you've heard the name Alan Turing before. He's a very famous man. He invented this thing called the Turing machine, which is a mathematical model of computation, how every computer under the sun ever made or ever will be made will work. And so yeah, every computer program can be modeled by a Turing machine, right? We have actually just, with loops, with a while loop, we've learned just enough C++ so that we can simulate any Turing machine. And you know what that means? We can create any program that has ever existed or ever will exist now with our current knowledge of C++. It might take you a long time and be very ugly code, but you can do it now, okay? You can make any program ever made or ever that will be made with your current knowledge of C++. So definitely pat yourself on the back right now. And I think you have some level of understanding why we're not stopping the class right now, right? There's plenty more to learn that will make your life a lot easier as a programmer, that will help you make larger programs that are more correct or more likely to be correct, things like that, or easier to write. So, but yeah, you have learned enough to simulate a Turing machine, and this is a big moment, okay? So I want you to remember it. With that, let's talk about things that can go wrong with loops. The easiest one is an infinite loop. Usually that's what goes wrong. That's when your loop never stops. Okay, your condition was wrong, and so it never stops. A new kind of bug is now possible because we can return to our previous code. We can return to that code forever, for example. Okay, that's unfortunate. And so if you ever have been to Cupertino and you've looked at like the Apple, like you can turn in and see the Apple campus, they named their street Infinite Loop, and the name of the address of their headquarters is 1 on that street, which is cute. So now you can laugh at that joke. So the simplest infinite loop is just a while loop that always repeats its body so that this Boolean expression is always true, right? It's always true and never changes. So I could say like 1 less than or equal to 2 in code at least. That's always true. Or I could just say while true. This will always repeat its body and never finish. Okay, so that's unfortunate, and that is not a good thing. But there are much more subtle ways of ending up with the equivalent of while true. I hope you can imagine. Okay, infinite loop.cpp, but here's just a simple one: while true, cout, new line. And so, yeah. Let me compile and run this, and we're going to have some fun watching it run. So, prepare yourself. Boop. There it goes. So I'm going to press enter, and it's just going to keep printing forever until the end of time. Okay, we don't like this. We would like to stop the program because we want to get back to our terminal prompt and hopefully fix it and recompile it. So to stop a runaway program on the terminal, you press Control-C. Okay? Control-C will stop your infinite loop and get you back to your terminal prompt. Okay? So always remember that. If anything goes wrong, Control-C to the rescue. Alright, so that is an infinite loop. Watch out for them. They will appear in your code eventually. Alright, so now that we've learned a bit about loops in general, let me show you some cool examples of loops. So here's probably the earliest algorithm of all time ever invented. It was invented by Euclid in 300 BC. It calculates the greatest common divisor of two numbers. So I'm going to show you this algorithm in a second, but remember what the greatest common divisor is first, so that you understand why it's cool. So let's pretend we want to calculate the greatest common divisor of 12 and 18. It's the biggest number that divides into both cleanly, okay? And so the way you find it, if you just, in math, separate each number into their prime factors, just pick out all the ones they have in common, including any duplicates. So it looks like 12 and 18 have 2 and 3 factors in common. And so 6, if you multiply all those factors together, right? That's the biggest number that divides into both of the numbers. So it looks like 6 is the greatest common divisor, or GCD, of 12 and 18, okay? And it just so happens that you can write a loop to calculate the greatest common divisor of two numbers. So let me show you that. Here is the algorithm. You don't have to really understand it. It'll take until CSCI 26 for you to fully understand it, but at least you can program it right now if I give it to you as a recipe. So let's pretend that the two numbers we want to find the GCD of are A and B. So we'll get those from the user, for example. And then repeatedly, while B is not 0, so we're going to keep on trucking while B is not equal to 0, right, in code, then we're going to replace B with the remainder from dividing A by B. So that is A mod B, right? And we're going to put that back into B. That's the line that we'll write there. And then we want to replace A with the previous value of B. This is just how the algorithm works. So A is the previous value of B before we took that remainder. It's the old version. It was this version, right? We're about to overwrite it, so we have to save it. So A is equal to that original B at the start of this iteration of the loop. Okay, so yeah. And then the second this is finished, that means B is 0, right? Because we continue while it's not equal to 0. So eventually that'll become false. And once we plop out of the loop, that means B must have been equal to 0, right? That's the only way to stop the loop. And at that point, A holds the greatest common divisor, which is cool. So it's just updating those original two numbers, and eventually A holds the right answer when B holds 0. Okay? So let's program this and have it run with 12 and 18 and watch it work. So, gcd.cpp. Let's get those two numbers. So we have A and B. We need to make those exist. So enter the first number, C and A. We'll do the same for B. And now we have A and B, and so we can do our algorithm. So while B is not 0, I want to replace B with the remainder from dividing A by B. So B equals A mod B. And then I want to replace A with the previous value of B before I took that remainder. So I better save that. So int original b up here, and then a equals original b. See, I'm saving that value of b before I replace it. That's what it's saying. Okay. And so that's just how it works. Just keep doing that process. Eventually, that'll make the number in b smaller, and eventually it'll get to 0, and a will hold the greatest common divisor of the two. So, see out. The GCD is a, whatever that holds. So, what were my numbers? 12 and 18? 18 and 12. Doesn't matter the order. So it looks like the GCD is 6. That's perfect. Nice. What about, I don't know, 42 and, I don't know, 18? Still 6. Nice. 42 and 21. 21 goes into 42. You can just pick some random numbers and discover that it really does work. But that is the greatest common divisor algorithm. It's a quick little loop, but now you know how to make it. Okay, so that's useful mathematical knowledge. Let's check how we're doing. Just fine. So the next example that I want to give to you is the guess the number game. So let's go back to that. Let's try it and actually get it right, okay? I want to be able to ask the user to type a new guess as long as they haven't hit the answer yet, okay? So here's what the loop looks like. Just continue asking the user for a new guess and telling them whether they were right or not, as long as their guess is incorrect. You see that? That is my condition of my loop. Once it's finally done and they got the number, guess is equal to number, we'll be done with the loop and we can stop the program. And the program can just end by itself. Isn't that lovely? So that's what I want to do now. So let's do guess the number properly. Guess.cpp, and what I'll do is let's go back out and see how much I can copy from last time. Because I'll take most of this code. It's not entirely wrong, right? There. So here's my guess program now, and all this stuff needs to happen still. This is the one. Remember that I had to keep on copying and pasting exactly this code? This is the stuff now that goes inside the loop. That's the beauty of it all. So I don't even need the exit call anymore, because once I stop the loop, if I put all this into a loop, once the loop is done, then the program ends, okay? So I just need to follow this process. So I want to repeatedly ask and check as long as guess is not equal to the number, okay? So something like this needs to happen. While guess is not equal to n, I think it looks like I'm calling it n here, do all of this. And this is going to work, usually, but I want to make sure it always works, even the very first time. I want to make sure that when the program starts and I pick my n, and I haven't asked the user for anything yet, I want to make sure that this is a true statement. Okay? I want to make sure that guess is not magically equal to n at the beginning, because right now it's undefined, right? It could be magically equal to n right now. So let's start off guess with a value that is guaranteed to never be a number between 1 and 100. So let's start at like -1, okay? Now it's guaranteed for this statement to be true the very first time we step into the program. Does that make sense? And so now we'll ask the user for a number. Maybe the secret number was like 50, but we guessed 20. And so we'll say we guessed too low, guess higher, and we'll go right back to the start of the loop. And our guess is now 20, and our secret number is the same, and it's still not equal, right, because we didn't get it right, which means we do it all over again. And it just repeats this process until the guess is finally equal to the number, because we keep updating it, right? Once the user gets it, we'll first print that they got it, congratulate them, and then this will become a false statement, right? Guess now is equal to n. And so that lets us out of the loop, right? That's how the loop stops, when the condition becomes false, and we can just go down to the rest of the code, and there is none, so we are finished with the program, and it ends. Does that make sense? That is how you do a correct guess the number program. So it just now, see the random number generator, picked a random number, and then we set our guess to be a nice default value, and now we're in the loop because guess is not equal to the number, whatever it may be. And so now we're being asked for a guess, 50. That was too high, guess lower. So it looks like the number that we were looking for was smaller than the number we typed in. So let's keep trying. And because guess is still, guess is now set to 50, but n is not 50, we have determined, right? So we're going to continue the loop as long as we got it wrong. Too high, guess lower. 15, 10, wow, okay. 5, ooh, interesting. 4, 3, okay. Randomly it was 3, that's cool. So, and this is just going to keep working, right? As long as the guess is not equal to the number, the secret number that we're supposed to be guessing, we're going to repeat this code, okay? The only thing I had to change was put this into a while loop, think of the correct condition, and make sure that the guess starts out in a way that makes this true at the very beginning, so that we're guaranteed to go through the loop at least once, okay? And so, oh man, nice. Randomly it was 50. That's impressive. 75, 85, 80, 77, 78, yay. Okay, so I think you get the idea, and it's fun. Code this up and play it. This is what loops are for. Nice, clean, only 24 lines of code. This is the stuff of dreams, guys. So, that's guess the number. Hopefully that makes enough sense. Please yell at me if it does not. But this is just another example of using loops. Okay? So while loops are one kind of loops. I told you that there are more. The second kind of syntactical loop, we'll get into recursion later in the class, which is something that functions as a loop but works a bit differently. The other kind of loop that actually is made up of just normal C++ syntax is called a for loop. And so instead of saying while, you say for, and the stuff in between the parentheses looks a bit weirder. You have some semicolons that separate 3 different parts of this parenthesized piece, and then again you still have the body, okay? So here is a for loop. A for loop, it's actually shorthand for a while loop, so you can't do anything different with a for loop. It's equivalent to a while loop. It just sometimes makes your life easier the way that it's set up, okay? So a for loop takes 3 pieces inside of the parentheses, and they're semicolon separated, okay? And here's the way it works. If you have a for loop that looks like this, what's going to happen is, of course, it runs the code previous, and then it starts with the initialization. This code right here is just a piece of code. It's just one line that you write that starts off the loop, okay? It only runs once, okay? And we put it there. And it never is looped back to. It just happens once, and then the loop goes off and does its thing. It initializes the loop, we say. Then, the next thing is the condition, and that's the same as the condition of the while loop. We always check that before repeating things, okay? That's what's happening in the for loop. Again, we still check the condition. If the condition is true, we then execute the body of the for loop, okay? And then we always, after executing the body, execute this statement over here called the increment, okay? It always happens immediately after the body is true. And after the increment statement is finished, we go back to the condition again, okay? So it's always repeatedly, as long as the condition is true, it's cond body inc, repeatedly forever until the end of time. Once cond is false, once the condition is false, then we're done with the for loop, just like for a while loop, and we do the rest of the code down here, okay? That is how a for loop works. And the reason it looks like this is because it makes some things a bit simpler. Remember my print from 1 to 10 code? I think you'll actually find, eventually, you'll come to prefer writing code that prints from 1 to 10 using a for loop instead, because it kind of packages up printing from 1 to 10 very nicely with this like initialization that starts our I at a certain value. Increment is always I++. And then the stuff that we really care about, like the meat of the while loop's body, we make just the normal body of the for loop. So let me show you all this. Okay, so here I have this. what was I calling all this code? Let me use the same name. So let's do print 1 to 10 with a for loop or something. Print 1 to 10 for.cpp. So here's a for loop that prints from 1 to 10. Let's see here. Or you know what? You know what I want to do? Let's not make that program. Let's re-edit the print 1 to 10 CPP program. I would prefer that. And I'm going to do this. Let's just make a new line just for spacing purposes, and then I'll write my for loop version. The for loop below is equivalent to the while loop above. Okay? And let me show you. Okay, so we say for, and then how do we start off the loop? We initialize things. Let's initialize a variable called I. Okay? It's not correct to duplicate our variable names, but I'm doing it for a reason. Int I equals 1. Okay? That's fine. Then, let's see. What do I want to do next? Then I want to do the condition. The condition is the same as the while loop's condition, right? I is less than or equal to 10. That's fine. And then I'll show you this in a second, the increment part. Then we have the body of the loop. What do we do inside of this loop? We print from 1 to 10, so we print our value of I. So I'm going to take that. That's still the body. And now, I want to increment I, but we have a spot for that in the for loop. It's over here. I++. And so this is the equivalent for loop to the while loop above. Okay, it's still going to print from 1 to 10, but I think it's cleaner. All those pieces, print 1 to 10, print 1 to 10. All those pieces make it a bit cleaner. So here it's printing 1 to 10 once and then twice. Same thing. Okay? And isn't this nice? This part of the body is like, this is the real work, right? This is the only real work that's happening. Only the real work goes into the body of the for loop. Everything that's extra, like fiddling around with the I variable, happens up here. Do you see that? That's kind of nice. So start I at 1, and then repeatedly, as long as I is less than or equal to 10, repeat this code, and then also remember to get ready for the next loop by incrementing I. Okay? That's a for loop. And I think you will grow to prefer this way. Maybe not now, maybe it's cleaner to think about while, but I think eventually you will prefer for. Okay, most people do. So let's talk about this. Let's go through this, like remember this diagram, and then we'll think about why this code is working. So again, we have I, starts out at 1, and as usual, we check the condition. Hey, is it true? Yes. Okay, print my I. That's the body. And then always after the body do we run the increment part of the loop. So now we make I 2. Okay? And then we check, hey, is the condition still true? We'll print my 2. Yes, it is. Print it, increment it, make I 3. Hey, it's still true, the condition 3 is less than or equal to 10, so print my 3, increment it, and then go back to the condition. Repeatedly, forever and ever and ever. We keep on printing. Eventually it's going to be like 9, we print our 9. Make I 10. 10 is still less than or equal to 10. Print it, increment it, and now we're done with the loop. Okay? Because this is now false. Okay, do you see how it's very similar? It's equivalent. It's the same lines of code, just shoved in a different place for the while loop. Okay? That's while versus for. Okay? So, again, I want you to try something. So take this code that prints from 1 to 10 using a for loop and change it so that it prints from 20 to -5 by 5s, still using a for loop. Okay? So, let's check time, make sure we're doing okay. Alright, how do we do this? Well, again, we better start the first starting value, right? The thing that we print first is always the starting value, and that is the value of I that it is initialized to. So we better change what it's initialized to, right? We better start it at 20 rather than 1. And then we want this to continue as long as I is not less than or equal to 10, because it will never start even, and definitely not less than or equal to 20, because it will never end. We want it to stop once it reaches -5, so we want it to continue as long as I is greater than or equal to -5, right? So this whole thing needs to change. Did you get that? And then between iterations, we go down by 5, so we don't go up by 1, so we got to change that too. Okay. So let's go here and make that work. So let's do, what was I calling the other one? Let's just say print 10 to 0. Okay, so print 20 to -5.cpp. Why not? So I'll take what I had. Boop. So I've got my I that needs to change, right? This needs to start at 20 because that is the first number I want to print. So I better start at 20. And then let me show you what would happen if I keep this I is less than or equal to 20. And then I want I to change by 5 each time. So I equals I minus 5. That will be my increment part. Really, it's decrement here, I guess. But this condition is always going to be true because I starts at 20 and just keeps getting smaller. So yeah, it's always smaller than or equal to 20. It'll never end. Print 20. Whee, and there it goes. See it? Printing by going down by 5 each time. Do you see why this is an infinite loop? This condition is always true. I starts at 20 and it continues to get smaller. So that's not the way you want to think about this condition. Usually when you're printing from something to something else, the condition should tell you when you stop, right? So you want to see when would, we have to include -5 somewhere in here. And that will help you notice the right direction of this inequality. So we want to keep going as long as I is greater than or equal to -5. Okay? And that'll work. Whee. So there it goes. Going down by 5, starting at 20. Does that make sense to you? So please yell at me if it does not. And let's keep on trucking. So yeah, we've come a long way. This is exciting stuff. The next few things I want to talk about, just very briefly, are, I'll give you one last demo, but before then I want to talk about just variables in a nutshell and show you some things that are possible and maybe some things that you shouldn't do. Well, let's talk about a word called scope, okay? The word scope means, inside of a program at least, which variables are alive, we say, okay? So what variables are visible at a current moment. The equivalent way of saying that is what variables are currently in scope, we say, okay? So for example, if I have int I equal 42, and like this is inside of main's curly brace, then I lives for the rest of main. I is in scope down here, we say, okay? If you make more parentheses, or not parentheses, but squiggly braces, like maybe you're inside of an if statement now or a while loop's body, you can unfortunately redefine a variable. It is not an error to do this, okay? Sadly. And then that's some inner scope. This is an outer scope like main. You can just keep on making variables. It's weird. So inside of loops, conditions, braces in general, you can create variables. We know that, right? What I'm trying to tell you now is their scope is important, and you have to worry about that. Those variables that you're defining only live between the opening brace and the closing brace. So for example, this I is a different I between inside of this brace. It gets a new life, all right? Or if I have an int j just in here, once its scope finishes, once its nearest closing brace appears, j goes bye-bye. It doesn't exist anymore, okay? So you go back here, j is not visible. And also, sadly, you can shadow variables. Okay, so let's talk about that. That's this. So you can make a variable in an inner scope with the same name as a variable in an outer scope. So here I've done that with I. What's happening is it shadows the outer version, sadly. It's very, very weird how this works, but this is how it works. And so in my printing demo from 1 to 10 with a for loop, I should not have called this I again. That's a very, very bad practice. I should have called it J or something, okay? Maybe I'll change it right now just to make you feel less uneasy, because it makes me feel uneasy. So I was creating a brand new scope with a brand new variable called I. That just shouldn't have happened, okay? I'll give you a bigger example of that in just a second. But yeah, this I is a separate variable from this I. So if you're touching this I, printing it out, changing it, you're affecting this one inside of these curly braces. But the second you get back out here, you have the old value of I again. It saved itself. It knows what it used to be. It has nothing to do with this inner one, okay? And let me show you that. It's a very, very bad habit to ever get into doing this. So just remember to never do this in the first place, and then you shouldn't have any trouble, okay? But that is scope. Let's do this. So here's something that I can do. I don't know. Here's int I equals 42. Here is, I don't know, if 2 is less than or equal to 3. Let's make another int I equals 55. I++, see out I, see out this I, I'll make a J, I don't know, 37, see out J, and let's talk about scope now. So take your bets as to what this is going to print, and then let me show you. Boop. It's going to print 56, because that's this I, right? It makes a brand new variable called I in this inner scope, in this inner curly brace. Same if this were a loop. It would have done the same thing. And I incremented it to 56, printed 56. And this is just printing 37, obviously, right? This I, though, is attached to this I. It does not know anything about this inner scope from this if statement, okay? So it's taken the old value, this original value of I. You see how that can mess up everything? So just never make a new variable with the name of an outer variable, and you'll never run into this problem. Another thing I can't do right here is print J. J doesn't exist outside of these curly braces, right? That's the wrong scope. It does not exist out here, so I won't even be able to compile. It's like J is not declared in this scope. Oh man. It's almost like these words I'm telling you, other people use them. So that is scope in a nutshell. Hopefully that makes enough sense. So J doesn't exist here. So sad. So that is scoping. Just try to never do this. That's just going to cause you pain down the road, okay? So that's that. And then I have one last demo for us, because loops are good for many, many things. And one of them is going through all of something, right? Another way of saying going through something is we say, instead of going, we say iterating, which is like, has to do with the Latin word for go, right? So we're still saying going through it, is just in a very pretentious way. So we say iterating through something if we're going through it. And we also say that loops, they iterate, okay? I talk about the iteration of a loop. That's like the body going once. That's just a term you'll have to get used to. But one thing you might want to do, one thing you might want to iterate through is a string. Go through all of its individual characters, right? So let me give you a demo of lowercasing every character of a string. So maybe here's my string S. It holds like all caps, some word, like blah. And we want to go through it, and by that I mean go through every individual index, right? And change it to lowercase b, lowercase l, lowercase a, lowercase h, okay? So we can make a loop that does this, that iterates through every possible valid index of S, like I can start at 0, that's my index, and I can make I 0, and then set like S at I to be the smaller form of that, and then I'll increment I. And now I can work on this index and keep going. Does that make sense? That's how we'll do it. We'll visit every index of the string, and we'll call the toLower function, if you remember that. That exists in the CC type header. You got toUpper, toLower is alpha, all those cool things. toLower is one of them. And that will reset the character to the lowercase version. Okay? It gives back the lowercase version. So let's do it first with a while loop, and then we'll do it with a for loop so that I can show you both ways of doing the same thing. Okay, so yeah, let's just go straight to code. So lowercase. Here's how I want to do this. Let's make a string. I don't know, s equals blah, and then let's lowercase it with the while loop first, and then I'll do it with the for loop second. Okay, so again, we want to go through every valid index in the string and do this kind of thing. Reset that character using the toLower function from CC type. So I'm using strings. I need that. I'm using toLower, so I need CC type. All right, so int I equals 0. That's the first valid index in the string s, right? And then I want to continue. I want to keep doing my lowercase this current index, right? Lowercase s at I, as long as I is a valid index. So when does it stop being a valid index, you might ask? When it gets too big, right? When it gets past the string, and that has to do with the string's size, okay? So while I is less than s dot size. That's what I want to say, because this size will give me back 4, but the valid indices into the string are 0, 1, 2, and 3. So I always want to be strictly smaller than the size, right? If I ever get equal to it, then that's not going to work, okay? And then I want to get ready to do the next index, so I'll do I++. All right, and now all I have to do is lowercase this current index that I'm working on, which is stored in I. So s at I equals whatever it was, but lowercased, so toLower. Yeah? And so it'll do the first one, because I is 0, that lowercase is the first character. Then we make I 1, it's still a valid index, so we're going to edit the 1 character, s at 1, to be lowercase. That'll do the L. And then we continue as long as we need to, and that will end up lowercasing the string. Yay. There it goes. So now it's all lowercase blah. And now let's do the same thing, but with a for loop. Okay? So for loop version we'll do down here. Let's set s back to capital so that we have an even playing field. And then, honestly, a for loop is just a while loop, just with some things moved around. So instead of while, I say for. Instead of saying this here, I'll say it here. For int I equals 0, I is less than size. My increment is incrementing I, right? So I++, that goes after these semicolons. And I don't want to introduce a new I in a different scope, so I'm going to say j instead. Just to not show you me getting into that habit. I'm just going to use j as my iteration variable, I say. Okay? And so this is the same. Let's see if I can show it to you at the same time. There it goes. So see how this is kind of cleaner? So start j at 0, continue looping while j is less than s's size, and then in between every loop, increment j to be the next index, and then work on that index of the string s. And so to print lowercase blah twice if I remember to actually print the string. And there it goes. Okay? So definitely yell at me, ask me questions about this if you're wondering about these new, any of this new syntax, any of the logic behind it, like why this is really lowercasing the string. It's important to understand, and definitely play around with this. I think you have a lot of tools now to build cool looking programs, like Guess the Number Game is probably the coolest program we've written so far, right? It just keeps getting better. So definitely play around, and that's all that I want to talk about in this lecture. So I will see you in the next one, and we'll talk about how to skip out of some loops.